In this video, we are continuing on with application problems of polynomial equations, and this next type is about projectile objects, whether it's a baseball going up or a rocket going up, anything that can be described in a projectile motion. So here on the left, it says when an object is thrown upward, its height s in meters is given by the equation s equals -5t squared plus vt plus h, where h represents the initial height and v represents the initial velocity. A ball is thrown upward from an initial height of 10 meters. It has an initial velocity of 23 meters per second. At what time will the baseball hit the ground, and how far from the object is the ball after 4 seconds? So in this problem, we have to plug in a couple things. So just starting with the original equation, -5t t squared, and instead of writing v, we're going to write the initial velocity of 23 times t, and plus initial height of, the initial height was 10 meters, so plus 10. So that's just plugging in the pieces of information that we know. Now we're going to actually try to answer these questions. At what time, so we're going to be solving for t, will the baseball hit the ground? So what is the height when the baseball's on the ground? If it's going wee, the height of that baseball is 0 feet. It is 0 feet in the air. So we're going to place s, because s was the height s with 0, and we need to solve for t. So we've got this polynomial expression here, and we have to factor it. Starting off, we want to see if there's any GCF. There's nothing directly in common with all three, but I do notice that my front coefficient, my leading term, has a negative coefficient. So I'm going to go ahead and take that negative out because it's going to make my life a little bit easier when I try to factor this. So 5t squared, now this will be a -23t and a -10. Okay, from there I have to multiply a times c. So a is 5, c is -10. So -50. I want factors of -50 that are going to add up to -23. So factors of 50, I'm thinking 2 and 25. That can get me to 23. And if I put the negative with the 25, that will add to -23. Now, since this front coefficient here is not 1, I cannot just plop those into my factors. I have to break up this middle term using these factors that I found, and then factor by grouping. So 0 equals that -1. Leave the first term alone. Rewrite -23 as positive 2t minus 25t minus 10. We group the first two and group the second two terms. We pull out the GCF of the first two, so they both have a t in common. When I take out that t, I'm left with 5t plus 2. In the second set, they both have a -5 in common. When I take out that -5, I'm left with positive 5t plus 2. Right? So -25 divided by -5 would be positive 5. -10 divided by -5 would be positive 2. If I did that right, these two terms should match, or factors. So I'm going to go ahead and take out that common factor as 5t plus 2. And what's left when I divide that out? T minus 5. So that was all just factoring. Now, because it's set equal to 0, we can use the zero product property, which says I can set 5t plus 2 equal to 0, and t minus 5 equal to 0. I would subtract 2 here, have 5t equals negative 2 divided by 5, and t would equal negative 2/5. Over here, I would add 5 to both sides, and t equals 5. Then we evaluate our answers. So I have time equals negative 2/5. Well, we're not time travelers, so we're not going to have a negative 2/5 seconds. So that one can't be a solution. No negative times. So that means that time must be 5 seconds. So that answers the first question. At what time will the baseball hit the ground? Time was 5 seconds. The second question is, how far from the ground is the ball after 4 seconds? So for this problem, for the second part here, we're plugging in time and we want to know the height. So I would plug in s equals negative 5, replacing t with 4 seconds. Again, replacing t with 4 seconds. And then following order of operations to simplify. So 4 times 4 would be 16. And then we multiply. So negative 5 times 16 is going to be negative 80. Positive 23 times positive 4 is going to be 92. And then we add all this up. So negative 80, 92, and 10 leaves me with 22. And that was in meters. So at 4 seconds, the height will be 22 meters from the ground. Go ahead and try this example on the right. Alright, here we are. It says an Alpha 3 model rocket is launched from the ground with an A8-3 engine. Without a parachute, the height of the rocket h at time t seconds is approximated by the equation h equals negative 16t squared plus 144t. Find how long it will take the rocket to reach 288 feet. Alright, so we don't have to plug anything in here like we did there. They give us the full equation. The question is how long, so we're solving for t, for the rocket to reach 288 feet. So we know the height. We're going to replace h with 288. And we need to find t. So I have this polynomial I need to solve. And I'm going to start by getting everything on one side and setting it equal to 0. So I would subtract 288 from both sides. So 0 equals negative 16t squared plus 144t minus 288. Alright, from there we're going to factor. We always start with our GCF if we have one. And I also notice here that this leading term has a negative coefficient. So I'm going to go ahead and try and take out this negative as well. I'm going to check to see if 16 divides into everything, and it does. If it didn't, I would take out maybe 2 or 4, the greatest common factor. In this case, the greatest common factor happens to be 16. So I'm going to take out a negative 16. Which would leave me with a positive t squared. 144 divided by negative 16 would be negative 9t. And negative 288 divided by negative 16 would be a positive 18. Once I've factored out my GCF, I look at what's left. I have a trinomial, 3 terms. Front coefficient is a 1. So I want factors of 18 that are going to add to negative 9. Let's see, positive 18, but I want it to add to negative 9. So I'm thinking 6 and 3 multiply to give me 18. But if they're both positive, I would get a positive 9 in the middle. So I'm going to make them both negative, and negative times a negative would give me positive 18. Negative 6 plus negative 3 would give me a positive 9, a negative 9, which is just what I want. So negative 16 times that front coefficient was 1. I'm going to go straight into my factors of t minus 6 and t minus 3. I set each factor equal to 0. You could take that negative 16 and set it equal to 0, but it does not equal 0. So if that concerns you, you can just either divide that away or not even write this, because negative 16 will never be 0. The factors we care about are t minus 6 equal to 0 and t minus 3 equal to 0. I solve each equation for t. Here I add 6 to both sides. Here I add 3 to both sides. So that says 6 seconds and 3 seconds. So you might wonder, how can I have two answers here? Usually I get a negative one that I can throw out. Well, if it's a rocket, it's going to go up and come back down. So it could be at the same height at 2 different times. That's okay. It's okay to have two answers here, because it has to go up, it's going to reach that height, and then come down and reach that height. So this is why we're getting the two answers here. It's possible to only get one, or you could get two. And there you go. So how do we solve these types of problems? We plug in the height, whether it's on the ground and the height is 0, or they give us a specific height. We get everything on one side, factor, and then use the zero product property to solve.